So let's get started.
All right, thank you, Professor Chu. Good old Hadoop, how we love thee. My name is Jerome Mitchell, and I'm so excited to kick off a series of presentations related to cloud technologies. Today, I'll be talking about Hadoop, but I do want to acknowledge the Salsa HPC group who have been working hard to put today or and talk in today. So I intend to discuss the following. Why should you care about Hadoop? You probably already care about Hadoop. I mean, that's the reason you're here, depending on your specific application. I also talk about what exactly is Hadoop. I'll give an overview of Hadoop MapReduce and its distributed file system, HDFS. And also, I want to walk through an application step by step so that you guys can understand the underlyings of its architecture. And then I'll conclude with some references, and then we'll get started with using Hadoop with a hands-on presentation or demo. So there's no question that we're awash with a lot of data. I mean, it's coming in from Twitter, tweets, even about Future Grid and the summer school, and even clicking about different news articles or what's happening all around the world. And even on Facebook, I mean, there's photos posted creating the data deluge era, as well as YouTube videos. But the problem is that we're struggling to process and store it. And this is the reason why we're here. But even grocery stores care about Hadoop, because if you think about it, they have data that would possibly learn from what customer buys what, and so which would help in advertising. So we all have this data, and we need to be able to create more meaningful understanding about it. So what is Hadoop? So you're probably already familiar with this, but I believe iteration is the best way to learn. So when I first started with learning about MapReduce and Hadoop, I quickly learned that MapReduce was actually started by Google. Google has this proprietary implementation, and Hadoop allows you to have an open source implementation so that you can do meaningful stuff with it. Also, it has its Google's file system is HDFS, and Hadoop has its file system HDFS. And so what exactly is Hadoop? Hadoop is actually a collection of sub-projects. But today, I'm going to be explaining the HDFS and the MapReduce. Later on, my colleagues will talk about HBase and PIG, so I won't steal their thunder. So why Hadoop for big data? Well, it's probably the most credible open source toolkit for large-scale general-purpose computing. It's backed by Yahoo, Cloudera, it's used by Facebook, Yahoo, and many others. But there's also increasing support from Amazon Web Services, and it closely imitates the infrastructure developed by Google. And of course, it can process petabytes of data. So why do we even need MapReduce? Well, parallel and distributed computing is very difficult in my opinion, because you have to worry about all sorts of things, such as fault tolerance, I/O scheduling, monitoring, status updates, and the like. But with Hadoop, it does everything for you. The framework does everything for you. The only thing you have to do is focus your data on key value pairs, and I'll talk later about that. So you're probably already familiar with this, but MapReduce has this programming model where it's map and reduce. So given a map function as an input, a key and a value, I will produce from that map function a list of key value pairs. That would be also input to the reduce, and I'll also get a list of those key value pairs. So MapReduce, the programming model, has its origins from functional programming as well. So I just want want you guys to kind of take this image and make a snapshot in your mind, because throughout the workflow, I'm going to explain intricate parts of this. And also, I want to mention that there were a set of goals and assumptions made with HDFS, such as hardware failure. We know that machines fail. I mean, that's the nature of it. But HDFS is very fault tolerant, and it can recover from those faults. Also, there's this streaming of data. HDFS is more focused or emphasis on high throughput than low latency. There's large data, so it can support large data formats. And then also it has this coherency model of a write once, read many times. Also, it supports the idea of moving the computation to the data, which is a very important concept. So let's get started with the workflow. So throughout through this series, I'll explain the HDFS writes, then we'll analyze the data, then we'll store the data back to the HDFS, and then we'll read the client will read the results from the file system. So let's try to understand first the server roles. So there are three main components with this. There's the client machine, there's the master, and then there's the slave nodes. The name node, is responsible for coordinating and oversees the data storage for storing large amounts of data on this HDFS, while the job tracker tracks or oversees the parallel computation with that. Most of the machines are the slaves, and of course the slaves do all the dirty work of storing the data and storing the results. And so it's important also to note that the data node is a slave to the name node, while the task tracker is a slave to the job tracker. Also, I want to mention this thing called the secondary name node. The secondary name node, there's sometimes a misconception that it's a backup for the name node. But in fact, it doesn't really support high availability of that data. It's just, once in a while, maybe an hour or so, ping the name node to get its metadata and the such. But the name node is important also is that it's not in the data path. So each of these is independent. So I just want you guys to kind of understand that the data node and the task tracker are all located on the same machine. And this is because of its data locality. Also, if you have, depending on how large your cluster is, you can so for instance, let's say that you have 40 nodes in your cluster. Well, the name node and the task tracker might actually serve on the same node, but if you have multiple machines, then of course it can be on different machines. So Hadoop has this concept or this idea of rack awareness. And essentially, as a Hadoop administrator, you can configure the rack number to each slave data node in your cluster. Why do you care about this? I'm glad you asked. The reason is because of the data loss and the network performance. So for instance, if one node was to fail, then your data would be lost. So what it does, it actually has replications on each node, so that if one machine was to fail, that it doesn't cause such a problem in the cluster, in your Hadoop cluster.